All right, we're looking at question number 2 from the test 3 review. This one is one of many word problems related to ellipses, mostly looking at ellipses because they're the most relatable in real life. And this one I think might be one of the trickier ones, but the technique we're going to use with this problem can be applied to all of the ellipse word problems. So once you watch this video, do try out similar techniques, like putting it on an axis, making sure you keep track of what dimension you're working with, length or width, and then plugging things into the equation that you come up with. Those are all techniques that you're going to use for all the other word problems as well. Okay, so the first thing is reading the problem as usual. A racetrack is in the shape of an ellipse. So I've got two ellipses drawn here because you can interpret it either orientation. It is 80 feet long and 60 feet wide. Now notice that this is talking about real length. If I told you that a racetrack was 80 feet long, you would not probably think, oh, let me measure from the center to the edge. But because we're looking at it on an axis and we're used to measuring only half the ellipse, that might be what you're thinking right away. So just remember, this is an entire racetrack, and when you're describing the length, you're usually talking about from end to end. So if the end to end is 80 feet long, then half of that, which is what we really care about, is 40 feet long. And no matter which way you orient this, the longer end is the 80 feet. Then we have 60 feet wide, and again, that's the entire width, so we care about half of that, which is 30. Oops, not 30 degrees. Okay, so there's our dimensions drawn into the racetrack, no matter which one you picked. What is the width? So that means we're solving for a W, 32 feet from the center. Now this question I think is a little bit tricky because it doesn't tell you in which direction you're measuring 32 feet. So you have to interpret based on what it's asking for. It wants to know what is the width, that's the short dimension, when you are 32 feet from the center. Now I couldn't measure out 32 feet along the short axis and then measured the width because that would be the entire width. It wouldn't matter how far away I was from the axis. If I measured out and then found the width, it's always 60 feet. So we must mean measure 32 along the long axis and then measure across the ellipse. So that means the length, or the dimension along the length, is 32 feet. So in either diagram, that means that we are looking for the width when you have measured out. Oops, that pen is not working. Let's try this again. You measure out 32, and then you measure across to find the width. So this dimension is 32, and we want to know what is that entire thing. If we did that over here, we're measuring out 32, and then again we want to know the width. Width is what we want. Okay, so now that I've set up what the question is actually asking, and this is one part that you would actually apply to all of these word problems. They're mostly asking for what is the height at a certain distance away from the center, or what is the width or length or away from the center. This is what we're looking for. We want to go across the ellipse, or if it's like a height where this is the floor, then maybe you're only measuring half of it, but you're still looking for a dimension across the ellipse a certain distance from the center in almost all these questions. So now in order to actually find that width, we're going to need an equation to plug into, because that's otherwise we need to draw this to scale and measure it with a ruler, which isn't going to be very helpful. So I need an equation for either one. No matter which orientation you work with, you will have an equation for it. They both have a center at 0. So this part's the same. And then the A dimension is 40 in both, but the placement of it is going to change. Here, we're going to put our A dimension underneath Y. And here, we're going to put it underneath X. Now, our B dimension is 30, so that goes in the other place. All right, so there's two different equations depending on which orientation you want to work with. So now we have to figure out what are we plugging in and what are we solving for. So again, if I look over here, what I need is the length or the width across the ellipse. So if I knew what this point was, then I would know how far away that point is from the y-axis. That would be half of that width. So I need this x dimension. I have the y one because that's what I actually drew in here. I said that's 32, that's my y dimension. So actually this point is x comma 32. Over here, if we label this as a point, I have my x dimension, it's 32, and I'm looking for the height above the x-axis because then I can double it. So I'm looking for y. So now if we plug those numbers into their respective formulas, this one we have the y, this one we have the x. So plugging in what I do know to solve for what I need. X squared, y squared, and over here if I worked this one instead, notice how now that we've plugged everything in, we're actually solving for the same part. We're looking for whatever number came above the 30 squared, and the rest of that equation is exactly the same. So even though we're looking for an x over here and a y over here, we're actually solving the exact same equation. So I'm going to only solve one of them from here on out. Basically, your steps are the same no matter which one you're working with at this point. So I'm just going to work on this one because it's on the right side. I need to subtract this term from both sides. I'm going to go ahead and square the 30. Over here I've got 1 minus 32 squared over 40 squared. Um, 40 squared is 1600. And then 1600 minus the 1024 is 576. And then now multiplying both sides by 900. And that turns out to be a perfect square. I believe it's 18. Yes. So y is plus or minus 18. And it's plus minus because, again, if we look back at what we're looking at, we actually have 2 points that have an x value of 32. One of them being negative 18 and one of them being positive 18. And so if we want the entire width, this distance is 18 up and 18 down. So the entire width would be double 18. So 36 feet. Over here, you would get a plus minus 13, or 18 rather, for your x. So that means this point over here is positive 18 comma 32, and this one is negative 18 comma 32. And again, doubling that would still get you your entire width. So now, just remember, you want to be able to apply these skills to other types of problems. So if we're ever talking about an elliptical ceiling, I bring that up because that is quite a few of the questions, then you're only looking at half the ellipse, but you can still find the height by finding a point along the ellipse. This would be a good way to do this, is to actually identify that point as x comma y, write down whichever dimension you know. That way you can keep track of which one you're looking for, whether it's x or y. Another thing is be forgiving about your orientation. That's probably not as big of a deal as you think it is. As long as you're keeping track of your x's and y's, you end up solving the same equation either way. And then finally, actually, I think that's all the advice I've got. Make sure you're writing your equations properly. Oh, another tip that actually works really well is always make the center of your ellipse 0, 0. It makes it easy to measure out and figure out what exactly you're looking for, and it also makes your equation much more friendly. All right, I think that's all the advice I can give. If you have any follow-up questions, leave a comment or email me, and I will try to address that. Thanks.